Hey, MathKook here. This video contains one of many examples in my Algebra 2 library. The rest of those examples, along with hundreds of other videos, are only available at mathkook.com. Let's MathKook it up. This question says, Tyler motorboats up a river and travels 24 miles upstream against a current of 3 miles per hour. The round trip upstream and downstream takes a total of 6 hours. What is the speed of the motorboat in still water? Okay, so this is a classic distance equals rate times time problem. So let's go ahead and set up a chart here. We are going to have upstream and downstream as our two categories. So for the first category, we have distance here. Well, they tell us that he travels 24 miles upstream. So that means distance is 24 miles. And going downstream is going to be the same amount of distance. Next, they tell us that he's going against a current of 3 miles per hour. So the rate, whenever you have an upstream downstream problem, or against the wind and with the wind type problem, you always do the rate in still water plus the current for downstream because you're moving faster. And then you do rate minus the current for upstream. So in this case, we don't know the rate. So we're going to say that V is the speed of the boat in still water. That's actually what they're asking for here. What is the speed of the boat in still water? So it's going to be V, and then the current is 3. So if you're going upstream, it's going to be V minus 3. And if you're going downstream, it'll be V plus 3 because the current will be behind you if you're moving downstream, so you'll move faster. Upstream, you'll move slower because the current will go against you. Next, we have time. So we're saying time is going to be the hours to go upstream. So you could have easily made it downstream, but I just chose to make it upstream. So this is T. And they tell us that the round trip upstream and downstream takes a total of 6 hours. So if it takes T hours to go upstream, how long does it take to go downstream? So this is tricky. It's going to be 6, the total time, minus T, because we don't know what T is. So there is our setup here. So let's go ahead and do our upstream here. We'll do our downstream over here. So our upstream equation is simply 24 equals V minus 3 times T. So 24 equals, I'll put the T in front, T times V minus 3. And then for the downstream equation, it'll be 24 equals V plus 3 times 6 minus T. So those are our two equations that we're going to work with, and now we have to do some algebra to solve. So it looks like comparing the two equations, the upstream equation, it's easier to solve for a variable here, and that variable is T. So I'm going to go ahead and solve for T. So I'm going to divide both sides by V minus 3 to isolate T. So the V minus 3's cancel, and then I'll write the T on the left side. So T equals 24 over V minus 3. We're going to take that T, and we're going to come over here, and we're going to plug it in right here for T. Alright, so this is going to be a lot of algebra. So we'll try to go kind of quick here. So it'll be 6 minus 24 over V minus 3. Next, we want to FOIL out these two guys because they're both binomials. So we're going to distribute the V to the 6 and then to the 24 times V minus, or over V minus 3. So let's go ahead and do that first. So that'll give us 6V minus 24V over V minus 3. Next, we'll distribute the 3 here to the 6 and then to this fraction. So 6 times 3 is just 18. So we have positive 18. Then we have minus 3 times 24, which is 72 over V minus 3. Okay, next we are going to multiply both sides by the least common denominator, which in this case there's only one denominator, it's V minus 3. So right here, V minus 3. So on the left side, we're going to distribute the 24 to the V minus 3, and we will get 24V minus 72 equals. Okay, so now we'll distribute the 6v to the v minus 3. That'll give us 6v squared minus 18v. Next, we'll multiply the v minus 3 by this fraction. The v minus 3's cancel, and we're left with negative 24v. Next, we multiply the 18 here by the v minus 3. That gives us positive 18v minus 18 times 3, which is 54. Okay, and then lastly, we multiply the v minus 3 by this fraction. The v minus 3's cancel, and we're left with negative 72. All right, so it's a lot of terms here. We're going to go ahead and combine like terms on the right side. So on the left side, we'll still have 24v minus 72 equals 6v squared. Then we have a v, and a v here. So if we combine those three terms, we will get negative 24v. And then we have these two like terms here. If we combine those, we get negative 126. Okay, we're getting closer. Notice we have a quadratic here because we have a v squared. So we are going to want to move these two terms to the right side. So we're going to subtract 24v and add 72v to both sides. And then when we do that, we will get 6v squared minus 48v minus 54. Okay, so now we have this quadratic. We can actually take out a 6. So let's go ahead and do that. So if we take out a 6, this will give us v squared minus 8v minus 9. All right, we're almost there. Now we just need to factor. So factors of 9 that multiply to negative 9 and have a difference of negative 8. So those two numbers are negative 9 and positive 1. All right, so now we set each of these guys equal to 0, solve for v. So v would equal 9, or v would equal negative 1. Now, which one of these answers is correct? Because they both cannot be right. Well, can I have a velocity of negative? Yes and no, but for this problem, we'll say no. You can't have a speed that's negative. So that tells us that our velocity in still water, because that's what v, remember v represented the speed of the boat in still water, our velocity is 9 miles per hour. So there is our answer. We can go ahead and cross out the v equals negative 1. Let's look at another example. Hey Kook, if you found this video helpful, hit that like button, subscribe, and drop a comment. For unlimited access to all of my Algebra 2 videos, visit mathkook.com. Thanks for watching.